Morning guys, afternoon guys, evening guys. This is the latest lesson and this one is on climate change. So the second part of section A, natural hazards and climate change, okay? So first of all, climate change, the definition is the change in the climate, obviously. And that could be warmer, that could be colder. But when we say climate, we do mean a period of about 30 years or longer, whether it's 100 years, 100,000 years, or even a million years. This is climate change. Now, climate change can happen naturally, and humans are also impacting the environment and causing climate change too. So one cause of climate change that's natural is volcanic eruptions. Now, volcanoes erupt naturally. There's not one person that sets off a volcano. Volcanoes happen as and when and can cause climate change. Now, they can affect the climate in the long term and the short term. So if there's an eruption, then the ash cloud goes in the sky. It blocks the sun's energy, the solar radiation. Therefore, in the short term, a volcanic eruption, remember this is natural, a volcanic eruption can cool the climate because the ash cloud is blocking the sun. In the longer term, the greenhouse gases that come from an eruption actually warm the climate. Now, this process is known as the greenhouse effect. More greenhouse gases in the atmosphere trap more of the solar radiation, making it warmer on planet Earth. Now, greenhouse gases include carbon dioxide, methane, nitrous oxide, CFCs. Now, these things warm the climate, and it's a good job they do, because without them, we wouldn't be here. There'd be no life on Earth. Now, as obviously the volcano can emit greenhouse gases, this can warm the planet up in the longer term. Now, this is the greenhouse effect. Another cause of this is the change in orbital cycles, so the Milankovitch cycle, effectively. Now, this is where the rotation of the Earth around the sun changes. It's not always the same. Sometimes we're closer to the sun, sometimes we're further away. Sometimes we're tilted more towards the sun, sometimes we're tilted further away. Now, this can make the climate warmer or colder depending on. So if, for example, we're closer to the sun and our orbit around the sun is nice and circular, this can lead to interglacial periods, basically warm periods. Interglacial, between glacials, between cold periods, so warm periods. Whereas if it's more ovular and we go further away from the sun, this is glacial periods where you get colder weather. Remember the Ice Age? You weren't around for it, but an ice age is caused by this cycle. The fact we were further away meant the climate was colder. The last natural cause of climate change is sunspots. Now, very simple. This, just like spots on your face, sunspots are spots on the sun. They are dark patches of energy that basically block the solar radiation from coming through that particular point. Say there was a spot here, it would stop the sun coming through that point and reaching Earth. The more sunspots there are, the colder the climate. The less sunspots there are, the warmer the climate. Okay? So climate change can happen naturally. 3 different reasons here how the climate changes. Now, of course, there is an element of human climate change too. Humans do actions that affect climate change. So any action done by a human that affects climate change is referred to as the enhanced greenhouse effect. This idea that it's the natural greenhouse effect, but enhanced, but sped up, but made worse by human activity. So for example, cars, farming, overpopulation, these things that I taught you before, adding more CO2, adding more methane into the atmosphere means that more greenhouse gases are in the atmosphere, which means more solar radiation is trapped as it enters Earth's atmosphere. It can't rebound back into space because the greenhouse gases are there to stop them leaving. The more greenhouse gases there are, the more solar radiation being trapped, the warmer the climate. Now, in terms of human actions that do cause climate change, I said a few there. Transport, burning fossil fuels for cars, for example. Farming, all the CO2 that farming generates, not just from digging the soil and releasing gases from the soil, but also machinery used in production of food for the mass amount of people, the over 8 billion people that arrive now. there's other ways we can look at maybe looking at evidence of climate change. So how do we know it's happening? Well, there's a few reasons. First of all, temperature records. We can literally see the temperature is going up. We have evidence of that when you measure temperature over the last 200 years. There's also ice cores. So basically ice cores are when you can see gas bubbles in ice from thousands and thousands and tens of thousands of years ago. And you can work out the levels of greenhouse gases in the bubbles. Don't forget, bubble is basically air. So you can work out the greenhouse gases in the bubbles and compare them to levels today. The other one is tree rings. You can actually see how much carbon dioxide was in the atmosphere many, many, many years ago, and again, compare it to now. Satellite imagery. We can see pictures of the North Pole and Arctic ice melting the land that it covers much, much, much less. We can also see the results of deforestation and how this has affected climate change. Don't forget, if you cut down a tree, you not only release the CO2 that was within that tree in the first place into the atmosphere, more greenhouse gases, but also you are stopping that tree by killing it from taking in carbon dioxide from the atmosphere. And this can ultimately lead to more enhanced greenhouse effect because it's a human cause, a human deforesting a tree. So that's climate change. They're the causes, natural and human. And in a future lesson, the next one probably, we'll look at what we can do to stop climate change, the difference between mitigating and adapting to climate change, something very topical in the news at the moment. So hopefully now you can see the difference between natural climate change and human-induced climate change, the differences between them and the extent to which they're important. Until next time, hope we're all doing well, guys.